Ready? This year's prize goes for contributions to our understanding of the evolution of the universe and Earth's place in the cosmos. The Royal Swedish Academy of Sciences has today decided to award the 2019 Nobel Prize in Physics with one half to James Peebles for theoretical discoveries in physical cosmology, and the other half jointly to Mayor and Queloz for the discovery of an exoplanet orbiting a solar-type star. Some biographical data about our new Nobel laureates on the screen. James Peebles was born in 1935 in Canada, in the state of Manitoba. And he has had his career largely at Princeton University, where he is today the Albert Einstein Professor of Science. Mayor was born in 1942 in Lausanne, in Switzerland. He is Emeritus Professor of Astronomy at the University of Geneva. Finally, was born in 1966 and is also from Switzerland. He's currently Professor of Astrophysics, both at the University of Geneva and at the Cavendish Laboratory of the University of Cambridge in the United Kingdom.
This year's Nobel Prize in Physics deals with groundbreaking discoveries about our universe. The last few decades have brought remarkable progress in our understanding of the development of the universe and Earth's place in it. Cosmic background radiation was discovered in 1965 and turned out to be a gold mine for our understanding of how the universe developed from its early childhood to the present day. Were it not for the theoretical discoveries of James Peebles, the wonderful high-precision measurements of this radiation over the last 20 years would have told us almost nothing. His discoveries are awarded with one half of this year's Nobel Prize. In October 1995, Mayor and Queloz announced the discovery of an exoplanet orbiting a solar-type star. This was a revelation that forever changed our view of the Earth's place in the universe. Since then, more than 4,000 exoplanets have been found. Recently, Earth-like planets with the potential to host life have been discovered. Professor Ulf Danielsson will now describe these exciting discoveries in detail.
James Peebles is awarded the Nobel Prize in Physics for discoveries in physical cosmology. The whole universe was in a hot, dense state. Then nearly 14 billion years ago, expansion started. The universe had cooled down to a temperature of a few thousand degrees and become transparent to light. We can, using our astronomical instruments, look back to these ancient times and study the cosmic microwave background radiation. At that time, when light lost its grip on matter, galaxies started to form. But it's only 5% of the energy in our universe which is in the form of ordinary matter like stars and planets and living beings. 26% is in the form of the mysterious dark matter. 69% is the dark energy that forces the galaxies to move away from each other ever faster. We are living towards the end of the era of the galaxies. Over the next several billion of years of expansion, our universe will turn into a darker and lonelier place. One can compare a universe to a cup of coffee. Most of it is, of course, coffee. This is the dark energy. Then a fair amount of cream. This is the dark matter. And then just a tiny little bit of sugar. This is the ordinary matter. This is what science has been all about for thousands of years.
Thank you.
Up until now. This is a picture of our universe. Looking back almost 14 billion years in time, this is the cosmic microwave background radiation. Already, at the time of its discovery, in the mid-1960s, James Peebles realized the importance of cosmic radiation. Cosmology evolved into a science of precision. Science of precision based on the mathematical foundation. Cosmology matured into physical cosmology. Mayor and Queloz focused on what is most important to us, the sugar in the cup. They awarded the Nobel Prize in Physics for the discovery of a planet in orbit around another sun. When a planet is orbiting a star, the star wobbles back and forth. In the same way as the sound of an approaching train changes its pitch when the train moves to, there is a subtle change in the color of the star. As the star moves towards you, the light gets a little bit bluer. When the star moves away, the color is shifted towards the red. The effect is tiny, and you need care and ingenuity if you want to detect it. The planet had unexpected properties. It was so close to its sun that its year lasted no more than a few Earth days. Its temperature was 1,000 degrees, and it was as big as Jupiter. Few had expected that such planets could exist. We had thought that other solar systems would be similar to our own. We were wrong. We now know there are many different kinds of planetary systems. In our own galaxy, our own Milky Way, there might be billions of planets. Some of them might be similar to our own Earth. Through the study of these exoplanets, we will learn more about the physics of how planets form and evolve and get a new perspective on our planetary home. This year's Nobel laureates in physics have painted a picture of a universe far stranger and more wonderful than we ever could have imagined. Our view of our place in the universe will never be the same again.